Hello everybody. This is a video to explain you how to calculate an authentication signature. So here we're very careful about the hypothesis here is that Bob wants to build an authentication signature, compute this value, send it to Alice then so that Alice can check that this signature is really from Bob. So Bob is a sender and he calculates actually builds S from B to A, from Bob to Alice, using the set of values that are available to him. That is SB, NB, and of course, to get authenticated, he will use his private key. And I'll show you why there's no danger using the key during the calculation. And so as he's a sender, he uses his own data. Then as he is sending to Alice, he will use public information from Alice, namely her public key. So actually, what will occur is a double ciphering calculation using, and be sorry for that word zoom, using NBDB or NAEA. So actually, computing the authentication signature is done in 2 steps, but the order in which those steps have to be made depends on the values of NA and NB. So the rule is use the lowest value of n for step 1. Then, of course, one uses the greatest value of n for step 2. So let's take an example. So if NA is lower than NB, then use NAEA first. Step 1, lowest value of n. So what Bob will do is calculate SB to the power of EA modulo NA. First step. Then, second step, use the greatest value of n, so the key associated to this n, use NB and DB. And NB and DB will be used over the first value which has been computed in step 1. So it means that actually the authentication signature from Bob to Alice will be equal to SB to the power of EA modulo NA, as NA is lower than NB. Then this value undergoes a second calculation step, which is to the power of dB modulo NB. This is the rule. If NA is lower than NB, then the calculation is done that way. Actually, this value, authentication signature from Bob to Alice, can only be checked by Alice because it's been ciphered with her public key. Then only Bob is able to produce it because he has used his private key. Moreover, and be very careful about it, as Alice will get the value of the authentication signature, though it's been built with DB, she won't be able to get the value of DB from that authentication signature. Okay, so what happens if then NB is lower than NA? Actually, it will only change the order of the calculation, but change nothing to the result, the fact that it will be an authentication signature and that Alice will still be unable to compute DB from it. Okay, so if NB is lower than NA, step 1 is done with the values of Bob, namely NB/DB. So the first step will be SB to the power of DB modulo NB. Step 2 uses NA and EA. So then the signature, this authentication signature from Bob to Alice will be equal to, so the value calculated at step 1 here, just write it once again, to the power of EA modulo NA. So if you compare the two expressions of the signature, it's just a matter of actually which pair of keys we have to use first, or one has to use first in order to compute the authentication signature.